So we now proceed to functional groups with a higher priority than alkenes and alkynes. They now become the priority functional group with the privilege of receiving the lowest locant number possible on the parent chain and becoming the suffix of the constructed name. So we begin upwards in this table with the amines. So the amines are alkyl groups bound to a nitrogen atom. They can be classified based on the number of alkyl groups attached to the nitrogen atom. In particular, an amine can be primary with one alkyl group, secondary with two alkyl groups, or tertiary with three alkyl groups, or quaternary with four alkyl groups and a formal positive charge. So how do we name them? There are two methods of naming amines. The IUPAC preferred method is the alkan-amine system. Essentially, we name the amine like a high priority functional group. In an amine, this is the nitrogen atom. We then look for the longest parent chain. Here we have 2 carbons, 1, 2. So our amine is an ethanamine. Next, we define the substituents, including the alkyl groups directly connected to the nitrogen atom of the amine. For these positions, we cannot assign a locant number. Rather, we assign it to the locant descriptor, N, okay? Locant descriptor N. Then, when we assemble the name, we get NN diethyl ethanamine. N in this case becomes a locant descriptor for the two ethyl groups, designating their positions to the nitrogen atom. Polyamines are also named in the same manner, but use a set of superscripts to distinguish each nitrogen atom. Let's take a look. So our parent chain contains 2 carbons and 3 amine groups. So it's an ethane triamine. There are 3 methyl groups, each distributed among the nitrogen atoms. And we begin locant numbering at the carbon with more amine. So that would be this carbon, 1, 2. Then we give locant descriptors to the amine groups. Here's how we do it. We first assign superscript numbers to the N descriptors based on the locant number. So if we have 1 here, then this would have 1, as well as this one. And if the locant number is 2, the nitrogen directly connected to this will get the superscript 2. Okay. For nitrogens in the same position, like these 2 nitrogens at locant number 1, we distinguish them using an apostrophe. And we can use more apostrophes when necessary. So when we assemble the name, we get N1 and prime 1, N2 trimethyl ethane 112 triamine. The other method to naming alkenes is the alkyl-amine system. This is only applicable to simple monoamines because in this system, the nitrogen atom becomes part of the parent chain. To illustrate, the parent is the nitrogen atom in this case, designated as amine. Then we determine the alkyl groups connected to it. We have 3 ethyl groups. Then we assemble the name. So we just compound them together to get triethyl amine. So what if the amine is not the parent functional group, or if we have a group that has a higher priority than amines? How do we name it as a substituent? Well, what we must do is use the prefix amino. Okay? For simple primary amines. For secondary and tertiary amines, we must create a complex substituent separated by parentheses. Okay? containing the alkyl name and the amino prefix. So it ends in amino. So a methyl group connected to the amino group is called a methylamino, separated by parentheses. If there are two alkyl groups connected to the nitrogen atom, then we order the two prefixes alphabetically and nest a parenthesis inside the complex substituent name. So we get ethyl methyl amino. Here are some cyclic saturated and cyclic unsaturated amines. They can all be substituted, and they are numbered starting at the nitrogen atom, or in some multiple nitrogen cases, at a specific nitrogen atom. Some of them you may recognize as the components of DNA, such as purine and pyrimidine. So they are cyclic unsaturated amines. Here's the single amine substituted benzene, known as aniline. In naming aniline, set number 1 at the benzene carbon directly connected to the amine group. If there are alkyl groups connected to the amine, then use an N descriptor. So N. So this would be 3-chloro. At position 3, we have chloro. N at the nitrogen, we have an isopropyl. And 4,5 at positions 4 and 5, we have 2 methyl groups. And this is the parent chain, which is aniline. Here's the full priority table applicable to most neutrally charged organic compounds. But did you know that there's a nomenclature system for charged compounds? Anions, negatively charged compounds, and cations, positively charged compounds, also have their own naming system, and they're surprisingly above in priority over all other functional groups. So let's take one important cationic compound, the quaternary ammonium ion. We name it essentially the same way we do a regular amine, but use a different suffix, which is ammonium, to signify that the amine is positively charged. So let's illustrate. We have propan ammonium, 3 carbon in the parent chain. We have 3 methyl groups, and at position N, those methyl groups are connected, and we set number 1 at the nitrogen atom, at the alpha carbon to the nitrogen atom. Then when we assemble the name, we get NNN trimethyl propan 1 ammonium. And in some cases, you may encounter that positively charged compounds will come with a pairing an ion, like chloride, for example. And so we can assemble this name with a second word like NNN trimethyl propan 1 ammonium chloride. So this would be a organic salt. Let's do some examples. So let's try number 1. So let's look for the priority functional group. That would only be the amine, nitrogen. And then we have 2 carbons for the longest chain, ethane. Okay. And then we have the amine. Okay. And so we assemble ethane plus the word amine, and we were starting with a vowel, so we must end in a consonant. So we'll remove the E. And so when we assemble the name, it would be ethan amine. There we go. Ethan amine. Okay. What about for number 2? Our priority functional group is the amine. And we have 1, 2, 3 as our longest chain, so this would be propan. Okay? And then we have a substituent with 2 carbons. That would be ethyl. And at position N, the nitrogen, that's where the ethyl connects to. And so, we can assemble the name N-ethyl propan. Okay? Let's not forget, since we have a 3-carbon parent chain, we have to do numbering 1, 2, and 3. Propan 1 amine. And ethyl propan 1 amine. Okay. Now let's go to the next one. Our priority functional group is actually still the amine, but now we have 2. Okay. So what if we have 2 functional groups? If we have a functional group, a parent functional group, with 2 of each in a compound. So we have to use the prefix di. Okay. So diamine. Okay, there we go. Okay. And we must choose the parent chain that contains the most carbons and also contains the most number of parent functional groups. So we cannot choose this one because it has only one amine connection. We have to choose this cyclopentane group. Okay. So that would be cyclopentane. Cyclopentane diamine. Okay. Now let's do the substituents. We have here a 5-membered ring, carbon ring, cyclopentyl. Okay. And then cyclopentyl is connected to N. However, we don't know which N specifically. Okay. So we have to give it a number. So this would be 1, 2, and 3. Okay. We chose this as number 1 because this has a substituent connected to it. So we want to maximize the substituents. So number 1, 2, and 3. So this would be N raised to 1. So when we assemble the name, at the nitrogen at the 1 position, we have a cyclopentyl group, and then that whole substituent is connected to the parent chain, cyclopentane, and at positions 1 and 3, we have the diamine. Okay, didn't have space, but here's the full name: N1 cyclopentyl, cyclopentane 1,3 diamine. Okay, let's go to the next one. Okay, so this has a benzene ring connected directly to an amino group. So we can use the predetermined name, which is, okay, this entire compound, this entire portion of the compound is an aniline. Okay. And then we have a substituent with 2 carbons, ethyl. Okay, and where is that ethyl located? It's in the nitrogen atom. Okay, and that's essentially the name. Just have to assemble N-ethyl aniline. Okay. N-ethyl aniline. Okay. Let's go to the next one. Now we have two amines again. Okay. But in this case, okay, we cannot set this whole thing as a parent chain. So we have to choose between a benzene ring or this methyl group. Obviously, aromatics are higher in priority over single alkanes, and so this will be our parent chain. Okay. And since it's connected to a nitrogen atom directly, we can designate this whole aromatic portion as aniline. Okay. Now, let's determine the substituent. So we have here a benzene ring, and a benzene ring as a substituent is phenyl. Okay. And here, okay, we name it having a methyl group directly connected to it. We'll name it methyl. And that methyl has a connection as well, which is an amino group. Okay? So if we combine those two words, amino, methyl, and then enclose it in parentheses, that would be a complex substituent. Okay? Okay. So in aniline, we always have to set number 1 or the locant number 1 at the carbon connected to the nitrogen of aniline. So this has to be number 1, followed by 2, then 3. Okay. And our phenyl is actually connected at the end position of our aniline. Okay. Now, when we assemble the name, okay, we can look at the alphabetization, A versus P. A comes first, so 3 aminomethyl and phenyl aniline. Okay, so let's check. 3 aminomethyl and phenyl aniline. Okay, now let's go to the next one. Our priority functional group is the nitrogen atom, or the amine, right here. Okay, so we have a diamine. Okay, it may be tempting to choose this one, this alkene, as our parent chain. However, it is not connected to both amines. Okay, so we have to choose, regardless of the length, the parent chain or the carbon that, or the carbon chain that is connected to the most amines. Okay, so that would be this one, this single carbon. So this is a methane diamine. Okay, so now we assign it. Let's find the substituent. So we have here a methyl group, and we have here an ethynyl group. Okay, so now when we assign the names or the numbering, this will always be position 1, so there's no need to actually use the numbers because there's no other number choice. So in this case, we need to label it N. Okay. Now we have to assign 1 with prime. Okay, and our decision would be based on the alphabetization of the substituent. So that would be E versus M. Okay, so this will get N and this will get N prime. Okay, so when we assemble the name, we should get N ethanol, N prime methyl, methane diamine. Okay, so it's N-ethanil, N-prime methyl, methane diamine. Now, let's go on to alcohols, which are a functional group of higher priority than amines. Alcohols are alkyl groups bound to an oxygen atom, like ethers, but the oxygen atom is also bound to a hydrogen atom. They can be classified according to the number of alkyl substituents connected to their alpha carbon, also known as the carbon atom directly attached to the OH group. So, in particular, they may be primary alcohol with just one carbon or another carbon connected to it. Secondary alcohol with 2 alkyl groups connected to this carbon, or a tertiary alcohol with 3 carbon groups. So let's learn how to name them. Alcohols use the suffix "ol", where they are the priority functional group. In this case, we have an alcohol functional group which belongs to a 4-parent or 4-carbon parent chain, butanol. We have a methyl group substituent here, and then when we perform locant numbering, we give the alcohol group the lowest number possible, so number 2. Assembling the name, we get 3-methyl-butan-2-ol. If we have a higher priority functional group, we label the alcohol as a substituent using the prefix hydroxy. Okay, here's the single hydroxy substituted benzene known as phenol. In naming phenol, we set number 1 at the carbon alpha to the hydroxyl group, so it's this one. This can be substituted. So when we name this compound, we use phenol as the parent name, and then at position 2 we have the methoxy group, and at position 4 we have the chloro group. Alcohols can also have common names. Simple alcohols in particular use the common naming system alkyl plus alcohol. You may be familiar with isopropyl alcohol, which is rubbing alcohol, and vinyl alcohol, which is the primary component of polyvinyl alcohol, or PVA glue. Here are some other alcohols: ethylene glycol, benzyl alcohol, propylene glycol, and glycerol. These are usually present in food and cosmetic products, as well as solvents for e-cigarette liquids. Polysubstituted benzene alcohols are also found in the organic chemistry laboratory. Dihydroxybenzenes such as pyrocatechol, resorcinol, and hydroquinone. Here are some of them. As you can see, they are differed by the arrangement of the hydroxyl groups, whether ortho, meta, or para. And the same can be said for methylphenols, which are also known as catechols. Notice how the common names use the O, M, and P for O catechol, M catechol, and P catechol, which stand for the ortho, methyl, and para configurations. Here are some other common alcohols you may encounter in the laboratory. Alpha-naphthol, which is used for synthesis of dyes, and picric acid, which is a common explosive, which is used for the measurement of creatinine in urine, I think. Let's try some examples of alcohols. So here we have a 2-carbon, again 2-carbon alcohol parent chain. So this ends in ol, okay, and this is an ethane, but we will only be ending it in a consonant, ethanol. So this would be named ethanol. Okay, ethanol. Okay, let's go to the next one. We have an alcohol as our parent functional group. We have 3 carbons, 1, 2, and 3. Propan. Okay, but before we finish the name, let's do some numbering. 1, 2, and 3. So at position 2, we have our alcohol. Propan, 2-ol. Okay, let's see. Propan, 2-ol. Okay. How about number 3? So it may be confusing. It looks like you have 2 alcohols, but actually you only have 1, which is this alcohol, because it has to be connected to a hydrogen. So only this can be the parent chain. Okay, so this is a cyclopent. Okay, there's 5 carbons. Pentan. Okay, specify that it's an alkane. Pentanol. Okay, and let's define this substituent, which is actually an ether. Okay, so let's define this alkyl group as cyclopentyl. Okay, and then it's connected to an oxygen. Okay, cyclopentyl oxy. Okay, cyclopentyl oxy, and that's a complex substituent because of its ring nature. Cyclopentyl oxy. Okay, now let's do locant numbering. Since our alcohol is the priority functional group, we must give it number 1, and then 2, and then 3. So at position 1, that's our cyclopentanol. Okay, and then our cyclopentyl oxy is at position 3. So 3 parenthesis cyclopentyl oxy, cyclopentan. Okay, specify at position 1 that ends in our alcohol. Okay, so let's confirm. Okay, 3 cyclopentyl oxy, cyclopentan, 1-ol. Okay, number 4. Well, here we have a choice between an amine and an alcohol. And since an alcohol has a higher priority than an amine, we will prioritize the alcohol. Now this alcohol, OH, is connected to a benzene ring. And so we have to give it the name Okay, the proper name phenol, and automatically assign number 1 to this carbon. Next, let's define our substituent, which is an amino group, and so we call it amino. So this is at position 2. So if we do the name 2, at position 2 we have the amino group, amino, and then we end in phenol. Okay, so we have 2-amino phenol. Okay, 2-amino phenol. Number 5. Okay, so let's define. We have 2 alcohols here, OH, OH. That's our highest priority group. This is not an alcohol, this is an ether. Okay, so we only use these 2 to define the parent name. This is a diol, okay, because it's 2 alcohols. And then the parent chain is here, 1 and 2. So this is an ethene. Okay, ethene diol. Now let's define numbering. So we can choose number 1 to be either of these. However, we have to choose this one because this has a substituent. So 1, 2. Okay, ethene 1,2-diol. And let's define our substituent. This is an ether with a methyl group, so this is a methoxy group. Okay, so at position 1 we have a methoxy group, and then we have ethene 1,2-diol. Okay, so emphasis on ethene. We ended it in a vowel, started the suffix in a consonant. So ethene 1,2-diol. That's G. Oh, we forgot something. Okay, so again we have an alkene. Okay, so we remember that alkenes have stereochemistry, so we have to ensure that we're doing stereochemistry as well. So I guess a quick review is that we have this alkene here, okay, and we have a hydrogen here just to illustrate. Oxygen has a higher atomic number, so this will be the priority of this side of this carbon. On the other side, we have 2 oxygens, but this oxygen is connected to another carbon, so this set has a higher atomic number than this hydrogen, so this is the higher priority. And if you draw it in such a way that the 2 high priority groups are connected, should be able to see that we have an E configuration. Okay, so that's E, 1-methoxy ethene 1,2-diol. Okay, so remember, beyond the first organic nomenclature set, we still apply alkene stereochemistry in our examples. Okay, so it transcends beyond just carbons and hydrogens. Okay, so now let's go to the next one. Okay, so now we have 2 choices. Okay, we have to choose between this alcohol, okay, or this one, because the 2 parent chains are separated by an ether connection. Well, how do we choose? So we have to choose between propyl here and this ethyl here. Okay. Well, the deciding factor would be the length of the parent chain. So now we have two equal alcohols. What will be the tiebreaker for this is which parent chain is the longest. So in this case, this is a propyl or propane parent chain, while this is just an ethane parent chain. So this will not be our parent chain. So this would be a propanol. Okay. And then now we have to define the substituents. Okay. So we have here an ether. Okay. This whole thing is an ether. So we have to define as this first part connecting an ethyl group to this oxy group. So this is an ethoxy. Okay, and in that ethyl group at position 1, 2, okay, at position 2 we have a hydroxy group. Okay, so at position, okay, again, if we write the name at position 2 of that ethoxy group, we have a hydroxy group. Okay, and it's connected to an ethoxy group, and closing in parentheses, this is our complex substituent. Okay, now when we assemble the name, okay, we have to do numbering first. We set number 1 here because this has a substituent, and then number 2 closest to the parent functional group, and number 3 here. So when we assemble the name, that would be 1 parentheses 2 hydroxy ethoxy propan 1 all. Okay, and if the check, let's see, 1 2 hydroxy ethoxy propan 2 all, sorry, so number 2 propan 2 all. Okay, so there we go. So we end organic nomenclature 2 with the thiols, which are alkyl groups similar to alcohols but are bound to a sulfur atom, and that sulfur atom is bound to a hydrogen. Often they have an unpleasant smell and are responsible for foul and even poisonous gases. In the priority table, thiols lie between the alcohols and amines, so they are lower in priority over alcohols but above amines. So let's learn how to name them. So we name thiols much like alcohols but use the suffix thiol. So here we have a thiol group, and then we have a 4-carbon parent chain, so we name it butane thiol. Here we have a methyl group, and then by doing locant numbering, we have to give the lower number to the thiol. And forming the name, we get 3-methyl butane 2-thiol. If we have a higher priority functional group, we label the thiol group as a substituent using the prefix sulfanyl. An old method used in other textbooks would be mercapto, okay? But to be updated, let's use sulfanyl. let's try some exercises. So here, we'll just do the same actually. This is actually quite a uh, a copy of the original exercises in alcohols, but modified for thiols. So here, in this case, we have 2 carbons in our parent chain. This is our thiol. Okay. And then we have ethane. So the complete name of this compound is ethane thiol. So here we go, ethane thiol. Okay, let's go to the next one. Here we have the thiol group SH or HS, and we have 1, 2, and 3. So we have a propane group. Okay, propane thiol. So we have to specify the location. 1, 2, 3. So at position 2, we have our thiol. So let's name it propane 2 thiol. Okay, propane 2 thiol. Number 3. Okay, this is similar to the alcohols. Okay, in which it looks like we have 2 thiols, but actually we only have 1, and the other one is a sulfide. Okay, so here our thiol is this, and it has a higher priority than the sulfide, so we must name this entire compound. Okay, so we have a thiol, and we have what seems to be a cyclopentyl or cyclopentane. Okay, so cyclopentane thiol. Now let's name this. Okay, which is a cyclopentyl group substituent. Okay, and we have a sulfur group here connecting to the parent chain, so it's a cyclopentyl thio. Okay, thio versus thiol. Thio is the sulfide, while thiol is the thiol or alcohol analog. And then we have to enclose it in parentheses. Okay, and then when we do locant numbering, we start number 1 here, number 2, and number 3. Starting 1 here because the thiol group is right here. Okay, so when we start the naming, we have 3 cyclopentyl thio, cyclopentane at position 1, we have the thiol. So there we go, 3 cyclopentyl thio, cyclopentane, 1 thiol. Okay, let's go on to the next one. Okay, so we have an alcohol and a thiol. Well, remember that alcohols have a higher priority than thiols, so that means this is our priority functional group. So we have an alcohol. Okay, and then we have here a benzene ring directly connected to this alcohol, so it's actually a phenol. Okay, and then here we have a substituent Okay, so our thiol becomes a substituent, and so we name it sulfanyl. Okay, so in an alcohol, we have to give this number 1 and then this number 2. At position 2, we have sulfanyl, and then we have phenol. Okay, so 2-sulfanyl phenol. Okay, so this is an illustration of using thiol as a substituent. Okay, the same case could be said in number 5, where we have an alcohol group here, OH. So this is an alcohol, and that is connected to a carbon, ethene. Okay, ethanol. So when we do numbering, since that's the priority functional group, this has to be number 1 and this has to be number 2. Okay, and then we have here our thiol, which as a substituent is named sulfanyl, and we have here a sulfide, okay, with a methyl group, which is methyl thio. Okay, there we go. So let's separate that with parentheses since we use methyl thio. And then when we assemble the name, okay, we arrange M before S. Okay, 1 methyl thio, okay, 2 sulfanyl, okay, and then I worry it might get overlapped, but let's just continue. Ethane, okay, 1 all. Okay, now we might be missing something, which is, since we have an alkene, let's see if it has stereochemistry. So in this case, sulfur has the highest atomic number among all these atoms directly connected to the alkene, so this has the highest priority and this has the highest priority. Drawing them together and looking at this bond axis, you can see that they are on opposite sides or opposite sides, and so we have the letter E as our stereo descriptor. So E. Okay, so again, confirming that, I'll just erase the one that I've written. E, 1 methyl thio, 2 sulfanyl, ethane, 1 all. Okay, and lastly, for number 6, we do the same procedure. Okay, since this thiol has the longest chain possible, which is propane thiol. Okay, and then we have a substituent here. Okay, which is actually a spoilers, ethyl thio. Okay, and of that ethyl thio, we have position 1 and 2. We have a sulfanyl. SH is sulfanyl. So 2 sulfanyl. Okay, ethyl thio. Actually, we have to re-enclose it because it will become ambiguous. So we need to use two parentheses enclosing those two. Okay. So 2-sulfanyl ethyl thio propane. Okay, let's do the numbering on the parent chain 1, 2, and 3. So when we assemble the name, we have 1 parenthesis 2-sulfanyl ethyl thio propane 2-thiol. Okay, 1,2-sulfanyl ethyl thio propane 2-thiol. Okay, there we go. So I think the parenthesis was placed wrongly, so I'll just correct that. Sulfanyl ethyl parenthesis here thio. Okay, so at position 2 of that ethyl group, there is a sulfanyl, and that whole complex substituent is connected to the thio group, the sulfur group, and that whole substituent is at position 1 of our parent propane 2-thiol. Okay, so that's examples for thiols. Okay, so to summarize, we learned how to name groups with a lower priority than alkanes, particularly alkyl halides. We learned about fluoro, chloro, bromo, and iodo. We learned about nitro compounds, okay, with the prefix nitro, ethers using the alkoxy or alkyl oxy prefix, and sulfides which use alkyl thio. Okay. We also learned to name groups with a higher priority than the alkenes and alkynes. Particularly, we learned about amines, which use amine for the parent and amino for the substituent, alcohols, which use ol for the parent and hydroxy for the substituent, and thiols, which use thiol for the parent and sulfanyl for the substituent.